Sarah plays it safe. It's between 10 and 39. I love that. Smallest is 10, highest is 39. It took you a couple seconds to find that though, didn't it even? Because you have to go through the data set and find the small and the big and say, there's your range. Good. What if your data set had like hundreds of values in it? Then use Excel, which is something I teach you guys how to use in the quiz for next week, because we'll link it to Excel. So this is a little bit of a problem, man. How else would you describe the employees, how they're doing? Between 10 and 39, 20, which is between 10 and 39. 20, exactly. How else?
Average.
Good! What is the average? Oh, don't worry about answering that right now. You can figure it out if you needed to, right? Yeah, I'll do one of those later. So here's one way of collecting the data into a more organized format. Here's the same raw data down here. Same raw data. Here is an ordered grouping of the data called a frequency distribution. Okay? Now what that does is it breaks down the range. It takes Sarah's 10 through 39, but it breaks it up into ranges, and it gives us counts within the range. It gives us counts within the range. So it says there's a frequency of 1 from 10 to 12. Why is there a frequency of 1 from 10 to 12?
Only one is between 10 and 12.
Because there is one data point between 10 and 12. It's that 10 that's down there. Frequency of 2, 13 to 15. How come? 14, 15. There's the 2. 5, 16 to 18. 1, 2, 3, 4, 5. How is this better than the raw data itself?
Organized.
Love the organized vote. Yes, it's organized.
You can visually see.
Oh,
where the employees
good. You can actually visually see where the clumps happen. Remember the vote for 20? The vote for 20 Zach had? You can see where 20 is. 20 is in this range right here. That's actually pretty damn close to where a big chunk of the data lies. So good eye on that one, brother. Good. So there's a couple reasons why it's better. You also have a secondary clump over here, maybe. These little individual secondary clumps separated by zeros. Kind of fun. I didn't notice that when I had it broken down before. That's also a function of how I broke it up. How is it worse than having the raw data? How is it worse? You lose some accuracy, but more, I guess precision, probably more than accuracy, but you lose something. Madam, you got an average for me, don't you? That's how you crunch something.
Yeah.
You got an average?
Well, it's weird because it came out as 22.05, which there are no numbers.
Hey, that's okay. Check this out. This is the exact, hold that thought. Madeline got an average of 22.05. An average of 22.05. You add them all and divide it by 20?
Yeah.
Good. Hold that thought, hold that thought. This is the same frequency distribution. This is what we call a histogram. All it is it's a more visual look at the distribution. So you're actually seeing the distribution in 2 dimensions versus 1 dimension. Who prefers this over this? Anybody? Most people do, because that second dimension gives you some scale. The 5s are literally 5 times bigger than the 1s. A 5 and a 1 like this is like whatever, it's a 5 and a 1. But a 5 is 5 times bigger than a 1. That's what it should be, right? It should be 5 times bigger than a 1. And the 5 is 2.5 times bigger than the 2. Madeline said the average is 22, right around 22, yeah? But she said, but there were no 22s. Is that what you said? There are no 22 data points. 22 is actually right here in the 0 category. You don't have to actually have a data point that's at the average. We're going to explore this more on Tuesday. But what the average basically is it's a balance point. It's where if this was a tray of goods, where you put your finger to balance it. And the 22, the reason why it's a little bit more than Zach's 20, and even though your 20 was a little bit high as well, the average is it appears to be somewhere in here based on the mode. But because of those guys over there, the average gets pulled over towards that gap. And it's fun. We'll explore it more on Tuesday, I promise you there. Please, Sarah, go ahead.
Couldn't the average almost be kind of bad for the employees though? Because most of the employees are performing under the average.
Let's talk more in depth about that about 120 hours, if that's okay with you.
Okay.
I do want to talk about that. I want to talk about that, but I want to spend an entire day talking about that. Rather than just as a sideline. Yeah, averages can be deadly to talk about because they can give you extraordinarily skewed results. And I want to have I have an entire day kind of ready for us to talk about averages by themselves. And yeah, which we know when to use them, how to calculate them, and when we shouldn't. So if you don't mind coming back to it, I'd love to. This is still nuts and bolts today, if that's okay with you guys. So you guys like the histogram better than the distribution? I kind of do too. I think it's a much more visual. You see those jumps. More data would be better if it would be good data. Well, I'd like to see if those were actually 3 distinct groups. I'd like to see if there was a group here, here, and here. Maybe this would even out so it did more like this. Maybe I'd actually get some stuff here with more data. I don't know. I might not. But if it did, then I can start asking questions. Like, if it is going like this, why is it going like that? Why am I getting a hump here and then a secondary hump here? What are they doing differently than these folks are doing? Right? And there's all kinds of answers, but in my opinion, statistics should create as many questions as it answers. Very often, statistics is used to prove things. I think that's the worst possible use of statistics. It should be used to uncover more questions about things. Like, why did that just happen? Not, here's why it should happen. Screw you. Why did that just happen? Why did that just happen? Unfortunately, the mass media markets want to prove something by showing you a graph. You'll explore one next week and one week after that, and probably one every week from now on in, showing you why it's not proving anything. It's just exposing something that may need to be looked at again. Cool? It's a fun noise.
Shouldn't, if 22 is in the middle,
Define middle.
the average,
Define, okay, so you're saying add and divide by 20.
yeah, well, shouldn't half be on this side and
That's not the average. That's the median. That's the median, a different kind of average. This is why I want to spend a whole day on it.
Okay.
Yeah, this is why I want to spend a whole day. There's the median average, there's the average, the mean average, and there's the modal average, there's the trimmed average, there's the harmonic average. Oh yeah! And they're all good. But let's not learn in 3.5 minutes. That's okay, that's all right with you guys. What I want to spend the rest of the day doing though, is just, I want to visit histogram-y type graphs. Each of the ones I want to talk about for the remainder of the class deal with this idea of a histogram, which Excel calls them a bar chart. If you ever use Excel to do histograms, they call them bar charts. Okay, so